Welcome to today's Oracle Machine Learning Office Hours. This is Mark Hornick, and we'll be learning about a new feature that was just released, OML4Py Universal Client, and Sherry LaMonica will be leading us through this. So Sherry, take it away.
Thank you, Mark. Hello, everyone, and welcome to this office hours session. I'm Sherry LaMonica with the Oracle Machine Learning Product Management team at Oracle. And today I'm going to show you how to get started with the OML4Py Universal Client. These are the things I have lined up. We'll start with an overview of the OML4Py Universal Client, provide details on prerequisites, system requirements, and the installation and configuration of the client, and then I'll show you a short demo. So let's begin with an overview of the OML4Py Universal Client. So with the Universal Client, you can connect to Oracle Autonomous Database or on-premises Oracle Database, versions 19C and 21C from a single client installation. And this enables the use of an external local client-based notebook environment like Jupyter, JupyterLab, or Zeppelin, and popular Python IDEs like PyCharm and Spider. Here's a look at the OML4Py architecture. The Universal Client package is installed on the client system. So today we support Linux 7 and 8, and you can use the client directly from the Linux command line, or you can use your favorite notebook or Python IDE. This client connects to Oracle Autonomous Database 19C or 21C, either on premises or in the cloud. And if you have access to both Autonomous Database and on-premises Oracle Database, you can connect to both database environments from a single standalone client package. When using the OML4Py client, you can choose your favorite client, notebook, or IDE. And the tools you see here are the ones I've personally tried with OML4Py, but others are available, and your choice will be the one that makes your work the easiest. Now let's look at prerequisites and system requirements. The OML4Py Universal Client is supported on Linux 7 and 8. It requires the Oracle Database Client or Instant Client, either versions 19C or 21C. You need the OML4Py Client installer, which installs the OML module, and this is the library that enables OML4Py functionality. A Python 3.9.5 installation built from source is needed, along with the supporting packages, cxOracle, scikit-learn, SciPy, Matplotlib, NumPy, and Pandas. And these are the Linux operating system requirements that listed on the right, and Perl env is required by OML4Py, and the others are actually requirements for Python. And here we have the open source Python library prerequisites that I mentioned earlier. These are the versions that you'll need to use with OML4Py 1.0. These are the versions that we've tested and certified with, and so you'll want to install these exact versions. Okay, moving on to the installation and configuration. So here are the steps 1 through 6 to install and configure the OML4Py client. And I'm going to go provide an overview on each one, and we'll start with verifying the prerequisites. So the first thing you want to do is check for any missing operating system dependencies using an RPM command, RPM QA, and then the name of the operating system library. And first you can see here, Perl env is installed because when I run RPM QA Perl env, it returns the version that I have installed on my system. But if there's no return value, it means the library is not installed and you need to install it on your system. So in this case, the ncurses devel library is not installed, and I need to install that before I can proceed with installing the OML4Py client. And installing any OS RPMs requires sudo or yum access, and you can configure a yum repository and do that right on your Linux system, assuming you have internet access. Okay, the second step is to install Python from source. So you can go to the Python website, the downloads release for Python 3.9.5, and you can use either of these source tarball. There's a tarball and a compressed tarball, and either source release works. And in this example, I am using the XZ compressed tarball, and I untar it, and then here we're building it with this shared library, which you need for embedded Python execution. So you configure it with enable shared, make clean, and then make alt installed so that you don't override the system Python. And these are the Python environment variables that you'll set. You'll want to add those to your bash RC so that they're there every time you start a log into your Linux session. Okay. The next step is to install the open source Python supporting packages. And these can be installed with a simple pip install, specifying the versions that you need. And I'm showing the pip install in this order to ensure that you get the correct dependencies and the correct versions of the dependencies. Okay, the next step is to install either the Oracle client or Instant client. I'm going to show the installation of the Oracle Instant client in these slides. So the Instant client is available from oracle.com downloads, and you can download either the RPM package or the zip package. Just understand that if you choose to install via RPM, that you do need root or sudo access. And then you may also optionally want the SQL Plus package if you plan on connecting using SQL. So you can download that same page under Tools, Optional Packages. And again, if you choose to install the RPM package, just know you'll need sudo or root access. And here are examples of both the RPM installation on the left and the zip file installation on the right. The RPM installation, you'll notice, gets installed to a hard-coded location. The zip file, you can install it anywhere on your system that you like. Either way, you need to set LD library path to the location where the Instant client files reside. And then again, optionally, to install the SQL Plus package, same thing. You'll want to install that SQL Plus package to the same directory where you installed the basic package. Now that the Instant client or Oracle client is installed, you can install the OML4Py client components. So this is downloadable from the Oracle Machine Learning from Python downloads page on the oracle.com on the technology network. And this is what the name of the installer, it's a zip file. When you unzip it, you'll get these 4 files, and the this Perl script, client PL, that's the installation script. And on the right, I'm showing if you pass help to the Perl script, you'll see all of the options that are available. So the default is to run this interactively, but you can script it if you pass, if you set ask to no and pass all of these parameters at the command line. So the default is to install, but the same script will also do an uninstall. You can choose to disable embedded Python functionality or AutoML if you choose to, although you would need to know that you wouldn't have a fully functional product if you did that. You can turn off dependency checking if you'd like, or you can specify to install the client to a specific directory using the target flag. And here is the client installation using the client PL script. The first thing that it will do is verify that you have the correct Linux version, Python version, and the versions of the supporting packages that we certified with. You will get an error if you don't, so you will be warned before the installation proceeds. Then it verifies that it has the correct Python configuration, so you'll want to look for that. And the operation, the default is to either install or upgrade. And then when it's finished, you'll see that the OML module is installed, and you'll get a successfully installed OML 1.0. The next thing you'll want to do is configure your wallet. So the wallet resides on a client system, and it contains TNS names Aura, which has the network configuration files that store the connection descriptors. And these are referred to as the TNS connection alias entries. And then we have SQLnet.aura, which has the SQLnet client-side configuration. The TNS admin environment variable will point to the wallet location on the client. And this is needed for the OML4Py client connection to the database during the invocation of either OML Connect, using the OML4Py Python interface, or if you're establishing a database connection from a SQL client, to use the OML4Py SQL interface. The TNS entries in the wallet require a bit of configuration by the user, including a database resident connection pool for automatic machine learning, or AutoML, and that also supports machine learning explainability, or MLX, and parallel enabled embedded Python execution. So for Autonomous Database, to download the wallet, you do need to be an administrator. So if you are an administrator, you can download that on your own, or you may need to ask your administrator to do it. You log into your cloud account, cloud.oracle.com, log in with the credentials that you provided when you created the account, and then select the Autonomous Database, followed by this database connection here. And then you can download the client wallet, and you will be prompted for a password for the wallet. Once you have the wallet, that wallet is good for, it works for every user in the tenancy, provided that you provide your username and password. But if you don't want to expose your Oracle Machine Learning user credentials in clear text, you can use MKStore to assign wallet credentials inside the wallet. And in this slide, what I'm showing is that I'm assigning wallet credentials to the medium service level in Autonomous Database. So I can connect to use the medium service level, but you can also repeat these steps for any of the service levels, low and high. And then the pooled connection is for the database resident connection pool. And I'll show you how that's used very soon. A few slides down. For Oracle Database on premises, you can use the same wallet. You will also use MKStore to add your database user and password credentials to the wallet. And the MKStore utility, it's the create credential flag that you'll use to add the credential to the wallet. And then, of course, you'll want to export TNS admin to the path where the wallet resides, so that the TNS alias connection descriptors can be found. Okay, so this is when you download the Autonomous Database wallet, this first entry is already going to be here. It's going to have the name of your database and then the service level, and then it will have an entry like this for every service level, low, medium, and high. And what you'll need to do is add the pooled connection. And in this example, I've also added proxy information to show you how to do that if you're behind a firewall. And you will need to essentially copy the medium TNS entry and just add server equals pooled to the connect data parameter. And then, of course, you can repeat this for all of the service levels that you'd like to use: low, low pool, high, and high pool. For Oracle Database on premises, you will add the TNS alias and server pool connection to the TNS names Aura in the wallet for Oracle Database as well. And this is just an example. And in this case, the TNS alias is myODB, and then we're adding the pooled connection with server equals pooled for myODB pool. In SQLnet.aura, you're going to want to add the path to your wallet. You're going to add SQLnet wallet override equals true to use the password credentials stored in the wallet when you're connecting to the database. And then optionally, you will add SQLnet use HTTPS proxy equals on to enable proxy tunneling if you're working behind a firewall. Now you're ready to log into your database. On the left, we're logging into Autonomous Database using SQL Plus with the TNS alias myADB medium pool. And as you can see, we're not exposing the user and password in clear text. And on the bottom, we're using the Python interface and passing empty strings to the user and password. But to the DSN parameter, we're passing the medium service level, and then for AutoML, the medium pool. Similarly, for Oracle Database, we can log in from the same client using the database, Oracle Database on-premises TNS connection alias myODB or myODB pool. And with the Python, OML4Py Python interface, we do not provide the user and password in clear text. And if we want to use AutoML, we pass the pooled connection, and the DSN is set to the medium level. These are just more examples. In this case, I am passing the username and password. And you can do that if you would like to as well. You would just need to set SQLnet wallet override to false. Okay, now I'd like to show you a short demo.
All right, so as Sherry gets that together, I'll just take a couple of minutes to comment on a new feature release we just made yesterday, as a matter of fact. OML4Py embedded Python execution now has a SQL API for Autonomous Database. And so you might recall that with embedded Python execution, users can run user-defined Python functions on engines that are spawned and managed by the database environment. And now you can do this from SQL in addition to a REST API, which was originally supported as well. And so if you go to our blog, blogs.oracle.com/machine learning, you can see details. I'll post the link for that in the chat in a moment. And Sherry will be covering this also in an upcoming office hour session. And just as a plug for our next office hour session coming up next week, we have a guest speaker, Steve Chamberlain from Sense Analytics, who will discuss how his team used Oracle Machine Learning with Autonomous Database to address two important use cases in healthcare claims processing. So with that, Sherry, I'll turn it back to you.
Okay, thank you, Mark. So what I've done here is this is Jupyter Lab, and I've installed it on my Linux machine, and I created a couple of notebooks for you guys to make it easy for you to get up and running with the OML4Py Universal Client. So the notebook contains a lot of the information that we already have in the slides, but in short, all of the prerequisites for installing and configuring the Universal Client, how to establish a database connection, and then actually how to verify the installation and configuration to make sure that everything is working properly. And then some notebooks to help you get started. I took if you're familiar with our OML4Py tour in our Autonomous Database template examples, I ran that against Autonomous Database and Oracle Database on premises from the same client, and you can have those notebooks after the session. They hit pretty much every area of the product and give you a nice survey of what's available. So very quickly, I'll go through this. Here are all of the prerequisites and pointers to the documentation, where to download the Universal Client, the instructions to install it in the user's guide, how to configure your wallets for Autonomous Database and Oracle Database, and more information on the MKStore command line utility. Something that's important to know, in order to use AutoML, model explainability, and parallel enabled embedded Python execution, you have to have a running database resident connection pool, we call it DRCP for short, on the server. And we pass that to the AutoML parameter in an OML Connect invocation. And it's automatically running on Autonomous Database. You don't need to do anything there. But while it's included with on-premises Oracle database, your database administrator has to start it using this DBMS connection pool start pool command. And then they can verify that it's running, and it will remain running until they run the stop pool command. If your connection pool isn't running from the client side, you try to use AutoML or machine learning explainability, you will receive an error that the connection pool isn't started. And so here are all the ways to establish a database connection using Autonomous Database. We covered this information in the slides, but I put them in the notebook as well. So here we are using the wallet. We are not providing our user and password to these parameters, user and password. Instead, we provide empty strings. And then in the DSN parameter, we provide the medium service level and optionally the pool service level to the AutoML parameter. And here's how we would do that using SQL+. If we'd like to use our username and password for any reason, we can provide them in the user and password parameters. And here are the equivalent examples, commands using SQL+. With Oracle Database, you do have additional options to establish a database connection. I'll go and show you this down here. If you're not using the wallet, you can provide the user, password, and DSN, if that's saved, for example, in a local tnsname.org, or you can provide it as a string, or you can provide your user, password, host, port, and SID, or user, password, host, port, and service name. And I have examples of each in here for you to make it very easy. You would just obviously replace your user credentials, your host, and port and SID and service name with the ones that we have in here. And those are the equivalent SQL commands. And then we have an entire section on verifying the OML4Py client installation. So after you've established your database connection from both Python and SQL, if you plan on using SQL as well, you'll want to confirm that you have the correct versions of the OML4Py supporting libraries, and you'll want to confirm that they're installed as well, and that you have the correct versions. And then you can run a quick test to verify embedded Python execution is working. Because in my experience, if anything goes awry during the installation, it's that something is not configured correctly for embedded Python execution. And that is true for on-premises Oracle database. Obviously, with Oracle Autonomous Database, everything is there and pre-configured for you. So here we're verifying that the database connection is established and AutoML enabled. So the OML is connected command will tell you if you are connected to your database, it will return true. But you can also check to see if AutoML is enabled, if you'd like, with this check AutoML equals true flag. It's set to false by default. You can also verify if embedded Python execution is enabled with the OML check embed function. And then I created this cell in the Jupyter Notebook just to make it easy for you to import your supporting libraries and verify that the versions are correct. And these are the versions that we want listed here. And then finally, I've provided some examples that validate that embedded Python execution is working properly, both from the OML4Py Python interface and the OML4Py SQL interface. So we're just creating a simple function, user-defined function test 1+1. Something to note, when you're using on-premises Oracle database, you will need to be granted the PyQ admin role. This is granted by default on Autonomous Database through the DW role. So to create a script using OML script create, I override it if it already exists in the script repository, and then I run the function using OML do eval, which will run a function in embedded Python execution with no inputs, and it returns true. So if you receive an error when you do that, usually it will say something like can't load shared library. Then usually what's happening is that the server components weren't installed properly, and you would need to look to the server installation. And this is the equivalent invocation of the test creation and running the test through the SQL interface. We create the script using sys.pyq script create, and then we run it using a select statement with pyqeval. And then when you're finished, you can drop the test script, either the test function, either using the SQL interface or the Python interface. And then I put steps in here just to verify that it no longer exists. So this will be available for you guys. Hopefully that makes it really nice and easy for you to get up and running with the client. And then I'll also provide you, these are the examples that are the OML4Py tour that hit, different areas of the product. And I have one for Autonomous Database and one for Oracle Database. So this is the one for Autonomous Database. You can see in the OML Connect, I'm using the wallet, and I'm using the medium service level and a pooled connection for AutoML. And then for on-premises Oracle Database, I'm using the wallet connecting to my on-premises Oracle Database server. And the other thing that differs between these two is the embedded Python execution. We have a REST API for embedded Python execution on Autonomous Database. We don't have that for on-premises Oracle Database. And that's it. That's all I have. If there are any questions, I'm happy to take them now.
Great, thanks, Sherry. One thing that came up is you were talking about the database instant client, and what alternative would you recommend for that, and why would you choose one over the other?
I always use the instant client, just so that you know, only because I'm only using it to connect. But with the full client, you do have the MK Store utilities immediately available to you. You have to bring them over to the instant client, and I'm going to have that. There'll be a blog associated with this session where I'll show you how to use MK Store with the instant client, but that is, as far as I know, that's the main advantage from an OML4Py perspective.
And one other question regarding Autonomous Database is the only option you have to use the Oracle Wallet when connecting to Autonomous Database using the Universal Client.
Today, yes. The non-wallet connection, I've tried it. It works for the non-pooled connection, so MTLS, but it does not work for the pooled connection today. And actually, we are looking into that, to getting that to work for a future release.
All right. Sherry, thank you very much for a great session, and we'll look forward to speaking with everyone next week.
Thank you, everyone. Thanks for joining the session.